In this video, we are looking at the modulus function. The modulus function turns anything positive. So if we have the modulus of -2, that is equal to 2. So if you have the modulus of just a positive 5, that's equal to 5. But the modulus of -5 is also equal to 5. So it turns anything positive. It's also known as the absolute value. And on the calculator, you'll see ABS. That means the absolute value. So if I press Shift and then get this up, it's represented by these two lines. And if I put in 5 take away 9, so that would be -4, but the absolute value of that is just 4. So it's just turning everything positive. It can't be negative. So find f of 3. That means substitute 3 into our function. So f of 3 is the modulus of 2 3s plus 1 take away 3. So 2 3s plus 1 is 7. So the modulus of 7 is 7. 7 take away 3 is equal to 4. If we have f of -2, we've got 2 -2's plus 1. So 2 -2's are -4, plus 1 is -3, but the modulus of -3 is just 3. It can't be negative. 3 take away 3 is 0. And we can check on the calculator. So we had 2 -2's plus 1. Then outside we had take away 3. And we get 0. Got 2 for you to try here. Pause the video, give them a go. So g of x is the modulus of x minus x squared. So g of 2, we're putting 2 in for x. So it's going to be 2 take away 2 squared. 2 squared is 4. So 2 take away 4 is -2. But we can't have a negative. So the modulus of -2 is 2. G of -5. So we're going to have -5 take away -5 squared. -5 squared is 25. So it's -5 take away 25, which is -30. So the modulus of -30 is 30. And again, you can check on the calculator. So we had -5 take away -5 squared. So we get out a positive 30. The absolute value is just how big the number is, not the sign of it. We're not interested in the sign, just the size of the number. Now we are going to draw the graphs of modulus functions. This first question says sketch the graph of y equals the modulus of 3 minus x. I'm going to start by drawing the original, which is the graph of y equals 3 minus x. So y equals 3 minus x has got a y-intercept at 3, and it's got a gradient of -1. For every 1 it goes across, it goes down 1. So it looks something like this, and it's going to cross the x when y equals 0, which will be 3. So that's our original graph. The modulus graph can only give a positive result. So all these bits above the x-axis we're going to keep. But when it goes beneath the x-axis, it's going to reflect back. Any negative is going to become a positive. So a -1 would become a positive 1. A -2 becomes a positive 2. So it reflects back up So it's always staying above the x-axis. So that's y equals the modulus of 3 minus x. And this original one was y equals 3 minus x. One for you to try. See if you can sketch the graph of y equals the modulus of 2x plus 1. Pause the video, give it a go. So let's start by drawing the original graph. It's got a y-intercept of 1 and a gradient of 2. So every one it goes across, it goes up 2. So something like that. It crosses x when y equals 0. So 0 equals 2x plus 1. Take away 1, divide by 2. This is at minus a half. So that's the original graph. The modulus is only going to give a positive result. So we're going to keep all the positives, all the bits above the x-axis, and where it was beneath, it's going to bounce back up. So that's the modulus of 2x plus 1. Here's another graph. Sketch the graph of y equals negative, so negative 1 times the modulus of x plus 5. So what does that look like? I'll start with just y equals x plus 5. So y equals x plus 5. It's got a y-intercept of 5, gradient of 1, and crosses the x when y equals 0, so that'll be at negative 5. So that's our original graph. That's y equals x plus 5. If I do the modulus of x plus 5, the modulus of x plus 5, so this isn't what we actually want. That's going to look like this. Y equals the modulus of x plus 5. But we want to multiply that by negative 1. So negative 1 times this, if we times it by a negative, instead of all the results being positive, all the results will be negative. So it's the same as when we have y equals minus f of x. All the positive y's become negative. So our graph will be this one. So it's going to cross at negative 5 now. So this green one is the graph we wanted to draw. One for you to try. Pause the video, give it a go. So y equals the modulus of 3x minus 1, and then plus 2 afterwards. So again, we'll do it in stages. Let's start with just 3x minus 1. So 3x minus 1 has got a y-intercept of negative 1 and a gradient of 3. It crosses x when y equals 0. So 0 equals 3x minus 1 plus 1 divided by 3. That is 1/3. The modulus of 3x minus 1 so whenever it was beneath the x-axis, it's a reflection. So instead of negative 1, it's going to cross at 1. So that's the modulus of 3x minus 1. And then we're going to shift it up 2 spaces. It's the same as f of x plus 2. A function moved up 2 spaces. So instead of crossing at 1, it's going to cross at 3. And this point here, the minimum point, instead of being at 1/3 0, it's now going to be at 1/3 2. So it's going to look like this. And that point is at 1/3 2. So the red one is our answer. This time we're going to solve an equation. So solve the modulus of 2x minus 3 equals 5. So the modulus of 2x minus 3 equals 5. If we think of the graph, so 2x minus 3 is this graph. So the modulus is this sort of shape. So where it equals 5, there's going to be two solutions. It's going to equal 5 in two different places. And we can think of it as two different equations. So two different lines. So this part of the line, the original part, is the graph of. This part of the graph is y equals 2x minus 3. And this part of the graph is the negative version of the line, y equals negative 2x minus 3. And so we can use that whenever we're solving these equations. We can just solve two different equations. So we're going to solve 2x minus 3 equals 5. And we're going to solve negative 2x minus 3 equals 5. So the positive version of it equals 5, and the negative version of it equals 5. There's two ways of getting the 5. So for the first one, plus 3, 2x equals 8, divide by 2, x is going to be at 4 for the original one. And for the second one, we've got minus 2x plus 3 equals 5 by expanding the bracket. Take away 3 from both sides and divide by negative 2, x is negative 1. So there's two solutions to it. X is 4 and x is negative 1. And one comes from the positive version, the original line, and one comes from the negative version, which is that reflected line. We can check that they both make sense. So if we substitute in 4, two 4s are 8, take away 3 is 5, modulus of 5 is 5, and for negative 1, two negative 1s are negative 2, take away 3 is negative 5, the modulus of negative 5 is also equal to 5. So we've got two solutions. One for you to try. Pause the video and give it a go. So we're going to solve two equations. So either 3x plus 1 equals 7, or the negative version of 3x plus 1 equals 7. The first one, take away 1, divide by 3, x is 2. For the second one, I'm going to times both sides by negative 1, then take away 1, then divide by 3. So x can be 2 or minus 8/3. And let's check them on the calculator. So let's have the absolute value, ABS, 3 2's plus 1, that's 7, and 3 times negative 8/3 plus 1, the modulus of that is also 7. Two more equations. We're going to do exactly the same thing. So we're going to get this modulus. I'm going to change it into a positive version and a negative version. And then it's good to check that they work at the end, because in some cases there could only be one solution. There could only be one intersection between the two lines, because if I found that the lines crossed So here's my original, and then the modulus did this. There could be an intersection down here, which isn't an intersection in the modulus graph. So we're just gonna, if we just find these solutions where both lines cross, and then we have to check that they work in the context of the modulus graph. So we can find where 3x minus 1 crosses 4 minus x, and we can find by where the negative version, negative 1 times 3x minus 1 is equal to 4 minus x as well. And then we'll just check that they work afterwards. So for the first one, plus x to both sides, plus 1 to both sides, and divide by 4. So we get 5 over 4. And for the other one, expand the brackets, plus 3x to both sides, take away 4, and half them. So then we'll just check they work. So we'll do 3 times x minus 1. So 3 times 5 quarters minus 1 is 11 over 4. And so 4 minus 5 quarters should be the same thing. Also 11 over 4. And then for the second one, we've got 3 times minus 1.5 minus 1. That's 11 over 2. And 4 minus 1.5 is also 11 over 2. So we can see that they both work. The other way of doing that without having to check they work would be to sketch the graph first, find the intersections, and then work out, find out how many intersections there are, and then work out what equation we have to use in order to do that. One for you to try. Pause the video, give it a go. So we are going to use the positive and negative version of our line. So we're going to work out where minus 2x plus 5 is equal to half x minus 1. And we're going to work out where minus minus, or plus 2x plus 5 is equal to half x minus 1. So for the first one, I'm going to expand the brackets, plus 2x to both sides, and plus 1 to both sides. And then divide both sides by 2.5, so negative 4 over 2.5 is minus 8/5. And for the second one, take away a half from both sides, take away 5 from both sides, and divide by 1.5. So negative 6 over 1.5 is negative 12 over 3, which is negative 4. I'm going to check they work for the question. So I've got negative the modulus absolute value of 2 negative 8/5 plus 5, which is negative 9/5, and that should be equal to half x minus 1. So half of minus 8/5 minus 1, negative 9/5. So both answers gave negative 9/5. So they work, and the same for the -4. So we've got -3. And for the other one, we also get -3. So we can see that they both work, both of those answers. This question says solve the inequality. So we want to know where the modulus of 2x plus 3 is less than x plus 4. So this time I am going to do a quick sketch. So I want to look at where the graphs are going. So 2x plus 3, the original has got a y-intercept of 3 and a gradient of 2. So that's the original. The modulus is going to look like this. It's going to reflect back up. And this is going to be crosses x when y equals 0. It's going to be minus 3 over 2. X plus 4 has got a y-intercept of 4. And it's not as steep. The other one, the modulus one, had a gradient of 2. This one's got a gradient of 1. So it's going to be a lot shallower. It's going to cross at -4 over here. It's going to look like this. So we want to know where the green line is bigger. So it's going to be in between the two solutions. So we're going to find these two solutions. And then in between the two solutions is going to be where our green line is bigger. So let's find out where the original line is equal to x plus 4. So 2x plus 3 equals x plus 4. Take away x from both sides. Take away 3 from both sides. That's at x equals 1. And the negative version of the line is negative 2x plus 3 equals x plus 4. I'll expand the bracket. Plus 2x to both sides. Take away 4 from both sides. X is -7 over 3. So this point here is at -7 over 3. So where is the green line bigger? In between these two answers. So in between -7 over 3 and 1. One for you to try. Pause the video, give it a go. So we want to know where the modulus of 3x minus 1 is bigger than 2x plus 3. So quickly sketch the graphs. So the original 3x minus 1, y-intercept of -1, quite a steep gradient of 3. And it'll cross the x-axis when y equals 0, which will be at 1/3. The modulus of it is going to cross at 1. Then we've got 2x plus 3, which is going to have a y-intercept of 3, and it's going to be shallower, not as steep, gradient of 2 instead of a gradient of 3. So there should be another intersection up there somewhere. Going to have to draw it really shallow in order to get the intersection in. And this should be at -1.5. So we want to know where the modulus is bigger. So the modulus graph is bigger outside of the two intersections. There's an intersection here, an intersection here. So the yellow line is higher, less than that one, and bigger than that one. So let's find the intersections. That's the solutions to the equation. So the original line, the white one I drew, is equal to 2x plus 3. Take away 2x, add 1, that's at x equals 4. And for the reflected bit, we've got minus 3x minus 1 equals 2x plus 3. That's minus 3x plus 1 equals 2x plus 3. Add 3x, take away 3, x is minus 2/5. So this is x is at minus 2/5. So where is our yellow line bigger? It's when x is less than minus 2/5 and x is bigger than 4.